Root cause analysis, what is it? Root cause analysis is a systematic process for identifying the root of a problem. In engineering and system design, we often react to the symptom because it's visible, it's on the surface, but the root is usually hidden deep under sometimes. It's below the surface. It's what sinks the ship. It's what sinks the unsinkable, hidden underlying causes that create the visible issues. Root cause analysis is one of the most important problem-solving tools in any industry, including the medical device industry. Yet many teams spend time fixing symptoms rather than identifying the true root cause of a problem. In this training, you will learn a practical step-by-step approach to conducting effective root cause analysis that supports FDA Quality System Regulation, ISO 13485, CAPA investigations, complaint investigations, and in general, continuous improvement initiatives. You will learn what root cause analysis is and why it matters, the difference between symptoms and root causes, how to ask the right questions during an investigation to find the root cause. Common root cause analysis tools, including 5 Whys and Fishbone Analysis, how to document findings and develop effective corrective actions. And finally, common mistakes that lead to ineffective investigations. You need to review that section. Whether you are an engineer, quality engineer, design engineer, manufacturing engineer, CAPA manager, or any other managers, this is for you. This training will help you perform effective evaluations, investigations. Let's take a tree for an example. The first thing that we see on the tree are what? Are the leaves. That's most obvious, that's visible. We can see the color, we can see the condition of the tree by looking at the leaves. But that is the symptom. So take, for example, somebody's weak or tired. Now, what is causing that weakness or tired? Because that's not the root cause. So if we trace that path, if we see what is holding that or what causing that weakness, we will see there's a fever as an example. But is that the root cause? No, we're not in the root yet. Fever is causing that weakness or the tiredness. But what is causing that fever? If we trace that path and go to the root, we may see that there's an infection of some sort. Now that is the root cause. We have to treat the infection in order to treat the symptom that we see on the surface. And therefore, the root cause of that symptom is the infection. But oftentimes, we look at the leaf and we think that that is the root cause. Or we look at the problem in the middle, thinking the fever is the root cause. And thereby, we are missing the root of the problem. Let's take an example of this. The symptom, what we see visible, and apply that to a real life example. The visible result or outcome of the problem, in this case, let's say circuit board fails the final test. That is the tip of the iceberg. That is the symptom, that is not the problem. So what is the problem? The problem is the soldering joint is weak and contains microfractures. But what happened? It wasn't like this last time. So is that the problem? Is that the root cause? It is not the root cause. So what is the root cause? So when you investigate further, you see that there are changes in materials or process. Let's take this complaint as an example. We recently had this complaint in our company, and this is about a leaking hose. And I hear there are two root causes. One is the hose got cut during opening. During opening of the packaging, the hose somehow got cut. That's one of the root causes that I heard. And recently I'm hearing that after investigation by one of the companies, one of the facilities involved in this situation, that the team found a cold slag or unmelted plastic. Now I hear that that is the root cause. So which one you think is the root cause? Are both of them the root causes, or which one? We'll come back to it later. You just make your choice and we'll come back to it later. What's the purpose of a root cause investigation or root cause analysis? It is to find the solution to a problem. But where does the solution come from? It is the direct result of the questions you ask. The true foundation of root cause analysis is to ask the right question, or the ability to ask the right question. And that requires clearly defining the problem statement or the scope of the problem. If the problem definition is not right, the question is not right, and therefore the answer cannot be right. This idea or concept is clearly stated here by two popular statements. G.K. Chesterton said, "It's not that they can't see the solution, they just can't see the problem." And Albert Einstein echoed the same statement, saying, "For once I know the proper question, I could solve the problem in less than 5 minutes." So what it means is, in order for to find the solution, you need to clearly understand the problem. Let's look at this example. A catheter shaft failing tensile strength tests. Now define the problem. Never state the problem as a proposed solution. Don't write, "We need a stronger glue." Instead, define the failure precisely. Catheter lot AF-482 failed the ISO 10555-1 tensile pull test, breaking at the distal hub during routine QC inspections. That captures the problem statement as a whole. It doesn't have any assumptions. It doesn't have any ambiguity. It clearly defines the problem. You need to clearly define the problem so you can ask the right questions, so you can have the right root cause, the right solution. Asking the right question gives you the right answer. Without the proper answer, you cannot find the proper solution. See, finding the solution is easier once you know the exact problem, once you can define the problem clearly. And this is why these two statements are so important. Remember, root cause is an investigative thinking process and a collective effort. The ultimate goal and ultimate focus of this is to discover what causes that issue on the surface that we see, not who made it. Sometimes who made it helps with the process, like a new operator, somebody who was not trained properly. However, it is not on the person, it is the process that we're looking at. I learned RCA, root cause analysis, during product design and development as an engineer many years ago. As you can see, it's not just for CAPA or complaint handling. It can be used in the design and development of new products, manufacturing process development, or optimization. Issues occur during product development, where you can apply these techniques during design, verification, and validation, and production transfer, just to name a few areas where you can apply these techniques. So how does it work? In the equation, Y represents the output or the outcome or the problem we are trying to solve. But you cannot fix Y directly because Y depends on X. While X represents the underlying variables, the inputs or constraints causing the Y. To change the output or Y, we need to identify which specific X is responsible for that. That is the core objective of RCA, root cause analysis. F is the function, and it represents the process steps or the cause and effect relationship that transforms input X into output Y. The solution is located by systematically analyzing data to isolate the critical few X factors or root causes, and then adjusting those process parameters so they no longer produce the flawed Y. And you achieve that goal by using some diagnostic tools and techniques that we are going to review next. Next, let's discuss some tools that we can use to help identify the root cause or causes. There are different tools or techniques, some of which are listed here. For our training purposes, we'll use the 5 whys and the fishbone diagram techniques. Remember, use of these techniques depends on your skill level and the complexity of the problem you are trying to solve. Think about driving a car. Different road conditions may require different skill sets and different vehicles to drive under these conditions. The same principles apply here. Depending on the complexity of the problem you're trying to solve, you want to use the right tool, but the team needs to have the right skill sets to be able to use the right tool. But most common tools are 5 whys and fishbone diagrams that you can learn. All tools are learnable. You just need practice and experience and training over time. Finding the root cause is a discipline that requires a skill set you develop over time, a culture or environment that promotes this discipline, adequate training, and teamwork with others across different functional areas. I also use a concept from engineering and project management called systems thinking. It allows you to view the system from the top and identify interfaces and relationships of components and subsystems within the system. I use this heavily during product development and system development with my team. I also use this concept of systems thinking in root cause analysis. This was part one of a two-part RCA training. When we return in the second video, we'll review some of the diagnostic tools, examples, and best practices that I implemented years ago that had a significant impact on finding the true root cause. We'll also discuss some common mistakes that often lead to ineffective root cause analysis. See the description below for additional information, and I'll see you in the next video.